All right, we're back. We are COMP397. That's web game programming in the winter 2018 semester, and we are week 4, part 2 of our broadcast. We just finished talking about our finite state machine build. We're getting into this game I'm going to show you. It's kind of a hello world that I use on different platforms called MailPilot. I originally built it back in 2011 on Python. I made a Python game with Pygame back in the day. And Andy Harris, who actually was one of the guys who Andy Harris books. He made this book called, I think it's this. Yes, he made these books that he had. One of them was called Game Programming back in the day, the L-line, right? Back in the day, he did it all with Python, and in his book, he talked about MailPilot as the game that he would make. And so what he did was he used assets from 1942. So 1942 game assets, right? They look like this. This might look familiar with what I'm showing you, right? So this is the plane, and there's lots of these little airplanes and stuff like this, and islands. And at the end of the day, he used the same assets just to demonstrate his game. So he wasn't selling the game. He was just making a game with the game assets. Very simple. And he made it with Python. So I took the game further, and I've been using it ever since, this idea of MailPilot, where you have a little plane, and I'm going to show you the assets really quickly. I believe maybe they're not included in here anymore. But really, at the end of the day, what it looked like was this. You go to my website. I had a version of it with Unity. And what you're going to make is this game. I talked about this last time a little bit, but we're going to make the rest of it today. So you're going to have this MailPilot. You have a start screen. You're going to click Start, right? You're going to have a plane, very simple, Yay. Right? Some Yay. Clouds. Yay. You have some bullet firing eventually, right? And when you hit the cloud, you die. When you hit the island, you get some points, right? When you kill the plane, if I can make it, I couldn't make it. And then you start over, you restart. Right, that's what it is. Yay. Very simple game. Yay. So I know it's really exciting, right? Not my voice, it's his voice. It's Andy Harris. He got these things. I'm using his assets from 2011. Okay, so it's not the same thing. I've been doing it, again, all over different platforms. Why? Because it's very simple. It gives you a basis. It's a hello world project. That's all it is. All right. It's not something that's going to be an exciting game, but all the elements are there for you to make something more interesting. Okay, so I got to give him some props because he did that. All right, well, we created our project, which is, lesson 4B. I don't want to mess it up. And I created earlier today this project you can also refer to called MailPilot Demo A. I'm going to make MailPilot Demo B because you guys are the B class, and we'll go over all the stuff we can with MailPilot today. So I'm going to close down Visual Studio Code, and I have MailPilot A. I want to make it from here, so I'm going to start off with this project, COMP397 W2018 Lesson 4B, which we just made. I'm going to copy it or duplicate it. Here it is. There we go. And change this to W2018 MailPilot Demo B. That's the one we're going to do together today. And I have a couple things to do. I have to get rid of the Git file. So if you're using a PC, you can you can go in there and remove the Git folder, or you can download it, this file, this 4B, right from GitHub. So you can go here and then download this thing. When you download it, then you can strip out the dot. You don't have a .git folder. There's no commits. For me though, I'm going to go in here, stop using Light Server for a second, clear the screen, and I'm going to CD to this new folder that I made. And I'm going to do it ls-al, which allows me to see all hidden files. And I'm going to get rid of my .git folder. So I'm going to go remove -rf.git, which removes the Git folder. In Windows, you just right-click on the folder if you do it this way and delete, if you can actually see it. And the way to do that in Windows is you have to expose hidden files and folders, right, through Control Panel. Otherwise, you can't see the hidden .git folder. Again, the alternative is just download my files and make a new folder out of it. Or you can just wait for a second and I'll make the new repository. Either way is the same. So I've done this, and what I want to do is I want to take this back into Visual Studio Code. So I'm going to open Visual Studio Code again. And I'm going to drag and drop this new project into Visual Studio Code. Here it is. And I'm going to rename my package.json again. So just instead of lesson 4B, it's going to be called mail pilot demo B. And same thing goes over here, mail pilot demo -b. I copy that and go in here and change these things just to make sure that it's just for complete. I don't really have to do this, but I'm doing it just because I want to make sure that the documentation is all ready to go. All right. One more thing I forgot to do earlier today is instead of create.js demo, this is going to be my mail pilot demo. Mail pilot demo. That's in the index.html. And now that I've got that, I'm going to go into my Git or my terminal and go git init, initialize git add dot, git commit -m, and then initial commit. And what this is going to do is just create my local repository again. I need to make my repository online for my mail pilot demo version B, right? And I have to do COMP397-W2018. There it is. And what I want to do here is grab these last two lines of code here and drop them into my terminal by right-clicking if you're a PC or Control-V if you're a Mac, which should put everything up on GitHub. So now I have my new repo, and it has nothing to do with the old one. So I've got my old template. You can leave it alone, but my new repo, which is up to date, is up online as COMP397-W2018 mail pilot demo B, which is what I'm going to be doing now. All right, so now that I'm up and running, there's some changes I got to make. First of all, I don't need in my start scene. First of all, I started off my project here again, which means I have to press Command-Shift-B or Control-Shift-B to start the task runner again. Here's my task runner. I'm going to start the watch task. And in my terminal window, I'm going to do light server. I got my light server running. There it is. But I don't need this screen. I don't need this screen anymore. I want to get rid of this stuff and start adding my mail pilot assets. I want an ocean. I want a plane. I want an island. And I want some clouds. Okay? And it's going to go in this screen right here. So let's start doing it. I'm going to go into my scripts, into my scenes. Here's my scenes. And if you notice in my scenes, I have my play scene. I have my play label and my next button, all this stuff. I'm going to get rid of it all. So goodbye. And all this stuff too. I don't care about all these functions and stuff because I'm not going to have buttons in my scene right now. I'm going to keep my main call. Inside my main function, the same thing. I'm going to get rid of all of the stuff that I'm adding in my scene here right now because I don't need any of it. Okay, so I got rid of it. I just cleaned up my play scene. And you have to do this too. If you're going to use my code base, you can get my code base, clean up everything that's in your start scene right now, and then start adding your game in here. So next week, when you do your first playable, leave my start scene the way it is. Leave my end scene the way it is. Just work on your play scene. That's the one I want you to work on, right? Because you have my finite state machine. Don't reinvent the wheel. Use my code, right? And then focus on your play scene. That's where you're going to put all your stuff. Okay, so I've cleaned it up. I'm going to go into my GitHub, and in GitHub, I'm going to basically say I cleaned up start scene. Oh, sorry, play scene. All I did. Notice I've only updated these files. One question I had earlier today was, what do I do with GitHub? I have a real problem. How do I manage it? Do I share my GitHub? Do I collaborate with all my users? What do I do? How do I, use GitHub? For now, I recommend this. Have one person manage GitHub, one person of your team. So for example, let's say it's Elsa. She's the manager of GitHub. Let's just say, all right? And if it's Elsa, that means that You pass your code changes to her. She adds those files into her GitHub or into her local repository. You have your own repository, your own GitHub, but she's managing the master. She takes those files, adds them in, you work as a team to incorporate them, and done. That's the easiest way to do it. Now, you could also do branches. You could also do a bunch of other stuff, like some kind of pull request if you want, and so on. That's more complex to do and requires a director level kind of way of doing things. You can also collaborate, but then you have to deal with something called merge conflicts, which you may have later on. So for now, keep it simple and have one person manage all the files, right? Even if you're working on it, you can have your own repository that you're going to, take some files, additions from your stuff, and give it to the person who's responsible for GitHub. It's the easiest way for now. Later on, we'll talk about other ways. Okay, cool. So we want to add some stuff into my play scene, and I want to add a couple of objects, but I don't have them. I have assets. Take a look. I've already given you the assets, right? So under assets, under images, I have my ocean. So here's my ocean, and it's really long. In fact, let's use GitHub. Let's use Fireworks for a second. So here's my old scene in Fireworks, and I'll just get rid of that. I don't need that. I'll make a new one, and I'll make it 640 by 480. Here it is. Okay, here's my scene in Fireworks. I'm also going to load up my ocean. Let's get my ocean going. So here's my ocean, and it's really long, like this, right? And imagine that I have my viewport for a second. Here's my viewport. I'm going to make a box, right? And the box is going to be 640 by 480. Let's try this out. So this is actually what you're going to see. And let's suppose, like we did earlier, that it's a transparent box, and it has some kind of yellow border that's like, I don't know, like 10 pixels, some really wide border. There we go. This is what you're actually looking at. The scene is made up of this. Put this down a little bit. Your scene is actually only looking at the 640 by 480. You might have other objects outside of the scene, like this one, right? But all you're looking at is at this particular view, which is you can only see 640 pixels by 480. That's all you can see. You can't see beyond 640 by 480. Okay, so it's like your camera. You don't have a camera in Create.js, but it's like you have this camera that's only looking at this part of the scene. All right. So what I want to do with the ocean is I want to do a trick. I want to take the ocean and slide it down like this until the top of the ocean gets to the top of the scene like this. As soon as it gets there, I want to reset the ocean up to the top. And I want to keep doing that over and over again, over and over, to create the illusion of a forever ocean, an ocean that is constantly looping over and over again, right? And the graphic I gave you is okay. It's kind of a tileable graphic, so you can't tell the transition between one part and the other, okay? It's not perfect. You're going to see where I'm going to show you that. But that's what I'm going to do with my ocean. But in order for me to do this, I need an ocean object, which I got to create in Create.js from scratch. Let's do it. So in my couple things I need to do first, I want to prepare. So to prep, I'm going to go into my core, into my game.ts, and I'm going to add in all of the kind of assets that I need here in my asset manager, my asset manifest. Let's add them all in. So here is my ocean, let's say my island, my plane, and my clouds. Okay, let's put them in. So this will be my ocean. I'm going to call it ocean. So the ID is going to be ocean. This is going to be my, let's say, plane, my island, and my cloud. Those are the assets. I'm going to rename them. So my ocean is actually going to be, I'm going to look at ocean.gif. And this is actually already there. If you actually look at your project, like I said, and if you go to the assets, and if you go to images, you can see that it's ocean.gif is right here, right? And the rest are named like how I'm going to show you now. So ocean.gif, it's called plane.png. There's an island .png, and there's also a cloud.png. So again, my preloading preloads all my assets in, everything I need for the entire game. I don't have sounds yet. I'm going to add them next week. So next week, we're going to do collisions and sounds, right? And by the way, just to say, next week is the last week before reading week. Reading week stretches between the 26th of February and the 2nd of March. For us, it goes until the 4th of March. So we're not going to meet on the 3rd of March. There is no class 3rd of March. So don't come on that Saturday because I won't be here, right? You guys have that week off. And that's a good time to catch up and to do some of your work for your alpha release, which is going to come in a couple weeks after that. All right, so this is I've loaded all my assets here in my game.ts. That's the first step. So I have my asset, okay? Now I got to make my object for it. So here's my object. Now you might think, and I got this question earlier, why don't I make a game object that all the other game objects inherit from? And I'm going to do that. But the ocean doesn't really match my regular game object because the ocean is not going to be centered. It's going to use the top left corner of its, to kind of move down. It's not going to move left or right. I'm not going to have control over it. It's not going to have a weird pattern to move or whatever. It's just going to move down every time and reset. Down and reset. It's going to be very straight. So it doesn't really need to inherit from anything. But I'm going to use some of the same stuff I develop on the ocean for the rest of them. So let's make a new object, new file. We're going to call this ocean.ts. And then here's how we start. We're going to say that it is of type, so a module, here's my module, which is objects. I'm going to export, can't type today at all. I'm going to export this class called Ocean, which extends, here's interesting, the create.js, just like the button, bitmap. So it's a bitmap, right? And because it has an is-a relationship with bitmap, right, we can use the same constructor that we did with the button, so to speak. So here's our button. Notice that we have this constructor. I can use the same constructor as the button, but cut it down a little bit. So I'm going to go back into my ocean and go into the constructor and then cut all this out because I don't need all of this. And I also don't need, for my ocean, I don't need X and Y coordinates, and I don't need to pass in the image string. I don't need to do that because I know that my ocean's only going to be an ocean ever. I can just put in ocean as the type that the object that I'm putting in. I also am going to have some private instance variables, maybe some public properties, like I do with all my stuff, and you should do too. Some private methods, and TypeScript allows this to happen, and some public methods. Here's definitely what the public methods are going to be. I'm definitely going to have a public start method, right, that returns void. I'm definitely going to have a public update method that also returns void. I'm going to have those two for sure, right? I might have some private methods, and I'm probably going to need a public reset method for now. Sorry, not public, private. Let's make it private. I'll need that reset method somewhere else, public. Reset, which is going to return void. Oh, bad today. And a private move method that's also going to return void. And one more, which is going to be a private, something called checkbounds. That's also going to return void. So these are all the methods I'm going to put in. So I'm just scaffolding out my class. All right, so that's what my ocean is going to start looking like. Let's add my ocean. Before I continue, let's add my ocean object to my index.html. So again, index.html. If you saw, I have objects. This is kind of a game object. So I'm going to put it on its own section. I'm going to have game objects. And I'm going to take just the script and copy paste and just change it. So it's going to be objects, and then it's going to be ocean.js. I'm also going to add this in as a reference for completeness in the core reference.ts, the reference for the references, where I'm going to put it before my scenes and after my scene class. So I'm going to kind of go in here and just copy this one and paste it in there and call this ocean. All right, so this, I've kind of made references already, so I don't have to do that later. In my ocean class now, I got to think what I'm doing. I'm loading my ocean, and I need something kind of like a speed. I need to kind of define a speed for my ocean. How fast is the ocean going to fall? And I'm going to use this private property called dy. So I'm going to say that it is private. It's going to be named dy for a change in y. I'm going to use an underscore for that. It's going to be of type number. Okay. And in my start method, I'm going to say that this dot underscore dy is equal to 5. So I'm going to set the speed of the ocean falling to 5. When I reset my ocean, I'm going to reset it so that it's off screen. Now, if you go back to my fireworks example, notice at the top of the ocean is some value negative, some negative value off screen. Well, I know because I've done this kind of thing before, that the top of the ocean is actually sitting at there's 3 screens for the ocean. It's actually 3 screens high, which means that it's 1440 pixels, and the top of the ocean is going to start at something like -960. So my reset then is going to say that this dot y, because it's a bitmap, I can use the y, x, and y, is equal to something like -960. Okay, that's what's going to happen. And on start, I'm going to set up the speed, and I'm also going to call reset. By the way, I've broken out the methods this way, so each method does one thing as much as possible, right? The start method, it initializes. So this initializes and creates initialized variables, let's say, and creates new objects in here. That's what we do in the start method. The update method updates the game object every frame. So it updates its position and all that kind of stuff. Okay. Check bounds, what it's going to do is check to see if some boundary, whatever it is, has been passed. We're going to talk about that. And the move method is going to move the objects to some new location. That's what it's going to do. Okay. And my reset method is going to reset the object's location, to some value, whatever I had set it to before. In this case, it's y is 960. That's what these things are going to do, right? So I've reset it. So when I start, I'm going to when I do in my construction, I'm going to call my start method. So I'm going to call this dot start, and start is going to reset and set my speed. And then every frame, what I want to do is in the update function, I'm going to move my object. And I want to also check bounds. So I want to see something when my object comes to a certain point, I want to do something. So that's what my update method is going to look like. So move and then check the bounds. What bounds am I going to check for the ocean? Well, I'm going to check to see when the top of the ocean, right, gets to the top of the screen. That's going to be the boundary check. Check the top of the ocean hitting the top of the screen. When it does, reset, which means that's what the boundary is going to do. I'm going to say something like that. I'm going to say if this dot y, the y is greater than or equal to 0, top of my screen, right? If that's true, then this underscore reset. I'm going to reset my object back. I'm going to call reset back to -960 again. What it's going to do, it's going to keep doing this, a loop. But it's not going to get there unless I move it. So in my move method, I'm going to say that this dot y plus equals to this dot underscore dy, the delta x, the delta y, the change in y, the speed, right? I'm going to add 5 pixels every frame, 5 pixels. It's going to move down 5 pixels. Okay, so that's the ocean. Okay, are you with me? So now I've got my ocean, but I need to add it to my scene. Right, so now let's go back to my scene. I got my ocean object, and I'm gonna go back to my scene object. So in my play scene, I've got nothing. Let's add an ocean object. So I'm gonna say something like this. I'm gonna say that I'm gonna make a new private object called ocean, which is of type objects.ocean. In my start method, I'm going to initialize it. I'm going to say this dot underscore ocean, right, is equal to a new objects dot ocean, and I need to pass in the asset manager, which is this dot asset manager. For now, I need to optimize this out. I need to stop doing this because we have a global asset manager, right now, but we haven't used it, and I'm not going to do it today. I'm going to do it probably next week. Now I'll do some optimization next week. Okay, and then I got to update the ocean. So in my scenes update method, I'm going to update the ocean. Here's my update. I'm updating the ocean every frame. In main, well, who calls main? Scene call, start calls main. In main, I'm going to add it to the scene. So I'm going to add the ocean to the scene. So how do I do that? I'm going to say that this.addChild, this dot underscore ocean. And it adds it as the only element of my scene. So in my main, in my play scene, I'm not going to have anything else, just an ocean. And the ocean is going to start doing it by itself. Every time it updates, the ocean is going to call its own update function, which is going to call in turn, just to let you know, let's go back to that ocean again. It's going to call in the ocean, it's going to call its update scene. Here's the update method. And the update is going to move the ocean and check its boundaries. If it reaches the top of the screen, the boundary check is going to reset it to negative 960, and the move method is going to keep moving it down. Okay? Let's see if this works. So I'm going to go back to my scene here. There it is in real time. Start, and you should see my ocean. Now, there's a problem with my ocean, and I want you to see if you can see it. So I'm scrolling. You see it? It just blinks really, really. There. See that? There. And so what's happening is it's not totally tileable. It's close, but it's not 100%. So what I could do is have 2 oceans. I can have one ocean and then followed by another one that's already pre-tiled. And then what happens is as it moves down, I move the other one to the top. And I keep doing that over and over again. So I have less of a transition like that. It wouldn't be so drastic. I have 2 skies, basically, if you will. And normally that's how it's done. We have 2 objects that are in the background that scale. And whether I have side scrolling, top scrolling, scroll all ways, I usually have more than one that I kind of use. But this is pretty good for now, right? I have something that looks like it's a never-ending ocean. All right, well, we got the ocean down. We need to add the plane, which is going to be controlled by my mouse for today. Next week or the week after we get together, I'll start adding additional types of controls like keyboard, gamepad, right? Other kinds of things that we can use, right? And there's different ways we can use controls in the game. So next week, when you do your first playable, even if you're going to use keyboard eventually, just use a mouse for next week, okay? It's okay. You're just proof of concepting. That's all you're doing. You don't have to do everything perfectly, right? For the guys who are doing their platformer, it's going to be kind of weird because you're going to move with the mouse, and then when you jump, maybe you have to figure out a way to jumping with a space bar. You can look at some videos to do that, right? And then when it jumps to the space bar, you do your own physics for now or whatever, or use Box 2D if you want. Okay, so I need a couple of more options, but I want to add this to GitHub. I did all these changes. Look, these are all the files that I affected. I affected 13 files to put in my ocean, right? So let's add these all to the staging area. I'm going to go here. I'm going to say added ocean to scene. Up on GitHub. All right, cool. Let's add in my plane, which is my player. Now, this is where we have to, we're going to start making gains if I have a super duper game object. It's almost like a superclass. I'm making, right now what I'm doing is I'm helping you make your game engine, right? I've got CreateJS. CreateJS is not a game engine. It's just a bunch of libraries. We're making our game engine here, right? But I want to be able to stop making the game engine at some point, right? We're doing a bit of the game engine today and a bit of the game engine next week, right? The game engine part we're doing today is the game object and some basic things. We did our finite state machine. That was part of it too. Next week, you need to do the collision part of the game engine, right? But there's going to be a time, guys, when you have to stop with the game engine. No more game engine inclusions, just gameplay. Because if you just keep working on your game engine, there's no game. You got to stop. Don't build a game engine, build a game is the saying, right? And so there's going to be a time where I stop doing some additions and give you stuff. What I might do is give you things like a particle system. I'll give it to you. I'll give you a math library, okay? I'm going to give you some of the stuff I've already made so that you don't have to do it again. If we had another 5, 6, 7, 8 weeks, yeah, I'll make you build it yourself. We don't have that time. So I'm just going to give you it, all right? And I got some example projects I'm going to give you so that you can just go and do it. Otherwise, my friends, if I try and make you build it by yourself, you'll never finish. And you know, you need to juice it up with particles anyway. So it'll be something we do. But for this one, we need a game object. So I'm going to make a new file. We're going to call it game object. A little different than what we've done before. And here's what the game object is going to look like. Again, it's going to be a part of the objects module. And we're going to export a new class called game object, which is going to, for now, extend the createjs.bitmap. Eventually, though, I'm going to change this to, extend createjs.sprite, because sprites, we can use sprite sheets, we can use sprite animations, all that kind of stuff. We won't do it today. Again, I'm not going to do too many more things today. Just like before, we need private instance variables. We need public properties, maybe. We also need some kind of constructors. We need some private methods. We need some public methods. Right? These are the things we need in our thing. Now, you can also consider this game object as an abstract class. We're never going to make an object of type game object. We're going to make a plane. We're going to make an island. We're going to make clouds. We're going to make bullets. We're going to make other things that are going to take advantage of game object, right? But I'm never going to instantiate it. So realistically, I could say I want to make an abstract class of type game object. For now, though, that causes some other translations we don't want. I'm going to leave it alone. Let's make it a class for now. We're going to treat it as if it's an abstract class. All right, so we need the same kind of constructor. I'm going to go back to my my ocean constructor and grab that constructor for a second. Actually, I'll grab the one from the button, I mean, because it's kind of very close to what we need to start off with. So here's our constructor. We're going to put it in here. We need this stuff, but I don't need X and Y. So I don't need this part here again. Like I said, I do need my image string though, because I want a different image string every time. Island, plane, whatever cloud it's going to be. This is where the image string is going to come from. Eventually, like I said, I'm going to optimize and take away my asset manager. I'm not going to need that anymore. For now, let's leave it alone. I don't need this part. And this part is good, but I'm going to do it somewhere else. In fact, the place I'm going to do it is in a private method called initialize. Different than start in that it's going to be called by my constructor, my superclasses constructor. And what it's going to do is going to initialize some variables that I'm going to declare up here. So one thing I'm going to do is I'm going to make some protected variables, right? Protected is different than private in that my subclasses can use them. I'm going to make my two protected variables. One of them is going to be called _dx, which is going to be a number. And another protected variable, which is _dy, which is also going to be a number. I'm also going to create some other public variables, right? One of the public variables I'm going to create is going to be called width, which is going to be a number. I'm also going to have height. And I'm also going to have half width. This is going to be useful for collisions as well as other things, and boundary checking, and half height. So these things here are just variables that my super duper game object is going to have that's going to pass down to my other objects. So I don't have to do this again. I only have to do it once, right? So again, we're using inheritance and polymorphism here. By the way, like I said earlier, not the best way to do it all the time. It makes a really fat, colossal, massive object, right? That gets passed into everything else. Realistically, if we had the time, we would use an entity component system where I use components that I add into my objects as opposed to inheritance. Yes. You'll see. I need to do it because if I don't do public, then later on my subclasses won't be able to use them in the same way. I need to use them. I need to actually use them outside of them. You'll see it later. Okay. There's other ways to do it. You can make yours however you like. Most of the time in JavaScript is public anyway, but we're just using TypeScript to help us. That's all, to make it more object oriented. Okay, so again, dx, dy, we've got these things here. In my initialize method, I want to do the following. I want to say something like this. This dot width. I want to use that get bounds. I want to say that this is equal to this dot get bounds dot width. So I'm measuring it. I'm saying how wide is my object? I don't know. Measure it. This dot height is equal to this dot get bounds dot height. I'm only doing this once when I create my object. And this dot half width is equal to this dot width times 0.5, and this dot half height, I'm calculating all this ahead of time, is equal to this dot height times 0.5. I'm also going to do the regex and reg y. My ocean has the top left corner as the registration mark, but all my objects are going to be have the middle as their registration mark. Their focal point is going to be in the middle automatically. So I'm going to say that this dot regex, my registration point is going to be that this dot half height or half width, right? And this dot reg y is equal to this dot half height. So this sets up my object in the correct way. Also, one thing that all objects have, because I'm inheriting from easel.js bitmap, here's my bitmap from easel.js, here's the documentation. If you notice, because it's inheriting from display object, it has a property called name, which is a string. I want to set this property to the name of my object because I can identify later, cloud, island, plane, whatever, right? By name, instead of checking the type. So when in my constructor, before I initialize, I'm going to say that this dot name, and name comes from the superclass bitmap, right, is equal to image string, whatever the image string I'm passing in. All right, now some public methods that I'm not going to initialize. Start. Right? Again, this is along the lines of what I did with Unity. Update, which is every object is going to have their own update method. I'm also going to have some other methods. I'm going to have reset, checkdowns, and the other stuff that I had before in my ocean, but I'm going to make them public this time instead of private for a reason. So here's my public reset method. Oop. Reset method. I'm going to have my public checkbounds method. Again, you may decide to make these private if you so choose. It's up to you. So reset, checkbounds, what else? And move. Our move method. And so those things I'm not going to fill in because every game object is going to be different. the implementation for all these methods is going to be different for every game object. But this core initialize function is automatically going to be called by the constructor, which is going to do all this work for us. It's important we do so. All right, now that I have my game object, I'm going to add it to GitHub. I'm going to kind of go here, add it. I want to say added game object. And now that I have game object, I can, instead of inheriting from create.js.bitmap, I'm going to inherit from objects.gameObject, my super duper game object. That's going to help me have all the other stuff, right? So in my, and now things I'm going to do because I'm not ready yet. One thing I didn't do is add it to the index. I need to do that. And it's going to be added before my game object, somewhere up here probably, right? We need to do this too. I forgot to do that. And I'm also going to add it to my references. Again, you might say, why do I need to do that, Tom? You'll see later. I can't explain everything right now because no time. Truly. Because I want to, actually, the answer is, what I'm going to do is I'm going to make it so there's only one file, not all these files. There's too many files. I want to make it so it's one file that you generate, game. And in order for me to do that, I have to create a path for all my game objects so that it compiles properly. That's the answer. Now you won't know what that means until we do more. All right, so let's into my objects. Let's make our first game object called plane. So I'm going to right click and add a new file. I'm going to call it plane.ts. This is the first time I'm making a game object, but I'm going to use the ocean as a model. So I'm going to kind of select everything in my ocean and dump it in my plane. Now it needs to change. Instead of my ocean being ocean, it's going to be called plane. And instead of inheriting from create.js.bitmap, it's going to inherit from objects.gameObject. Now objects.gameObjects need to take in a constructor, right? Yeah, I need that. And instead of passing in just this, I only need to pass in the name. So ocean will be the thing I need to pass in. And I also got to pass in a reference to my asset manager because I've been passing that along. But eventually I won't. Eventually I won't have to do this. I'm going to call my start method, my reset method, my move method, and my check bounds method are all going to be public. And again, as Alexa said, you might choose to make it private. And make them public for a reason. There's some reasons why later on, I've made my game over and over again. I know that it solves some problems at some point. We can also later on decide that we're not going to make it all public. We're going to revert some of them to private. Just make sure I select all the ones I need. There it is. So cut those out and put them underneath here. All right, just relining this stuff so that it is renamed properly. It's a lot less work than if I typed all this from scratch. All right, so I've got my objects that's called plane, right? For sure, I've got my objects called plane. It says that incorrectly extends base class game object because my dy is private in type plane, and it's true. But I don't need this anymore because dy is already part of my game object class. I don't have to re-establish it anymore. I could do this. I know that my plane in the start method is not going to reset, so I can get rid of this because my plane is a plane, not an ocean, right? My move and my check bounds is important. My reset is going to be empty for now. My move is not going to be like this, and my check bounds isn't going to be this at all. But I have my basic methods that I can refill. So what is my plane going to do? My plane is going to move by my mouse. But in order for me for my plane to move by my mouse, it has to get a reference to the stage object. Now there's two ways to do this. I could say something like this. This.parent.parent.parent.stage. Mouse x. It's crazy. Or in my game object, in my game.ts file inside my core, when I establish my stage on start, I can pass in a reference to my global object. I could say that objects.game.stage is equal to stage. And what this does is it makes a reference to my stage, and I hold it in my global object. And then I just have to call objects.game.stage.mousex in my plane object. So if I go back to my plane object, in my move function, right, which is down here, I could call it something like this. I could say that this.x, so the x coordinate, the left and right movement of my mouse, will be according to my my plane. It's going to be my mouse movements. So it's going to be equal to objects.game.stage.mousex. So wherever my mouse is, that's where the x coordinate of my plane is going to be. For my y coordinate, I'm only going to have my plane stay at the same level every time. It's not going to be allowed to go up and down with my mouse. It's going to stay at the same place. All right, so what I'm going to do then is in my start method, I'm going to say that this.y is equal to something like 430. I know that number because this is my Hello World project. I've done this a million times, and I've always set it to 430. Works fine. So it's going to keep it at the bottom of the screen. Okay. And this is all I need, right? Because in my update function, I check bounds. Check bounds doesn't do anything, but we're going to set up the check bounds in a second. Now we have to add my plane to the index.html as an object. So here's my ocean. I'm going to add my plane in there. Here's my plane.js. And I got to do the same thing into my core references. So here's my ocean. Here's my plane.ts. And in my scene, one more thing I got to check. I want to make sure that I said plane, not ocean. That's going to be really weird. There's no ocean moving around with my mouse. That's going to be really weird, right? So it's going to be my plane. Yeah, here's my plane. And in my scenes, under my play scene, I got to add a new plane. Now, I'm going to add it up here. So I'm going to say something like private plane is equal to of type objects.plane. In my start method, I'm going to instantiate it. I'm just going to copy this and paste and just change the names a little faster. So plane and plane, right? In my update, I need to update my plane. And careful here, when you add stuff to the stage, you need to add it in layer order. So if I add my plane first and then my ocean, my plane will never show up. It's going to be underneath the ocean, right? So we have to make my ocean first, and then my plane appears on top. Alternatively, what you can do is instead of this.addChild, you can say this.addChild at, and then you can choose a place, layer that you can put the child in. I don't recommend that. You have to keep track of all the layers. So what I want to do is add the plane to the scene, and this.addChild, this._plane. Guys, that's it. I'm ready to have my plane ready to go. Let's test it to make sure it works. So I'm going to go back to my scene, start, and we have my plane. But there's a problem. What's the problem? Here's the problem, guys. If I move my plane all the way to the right, I can cheat, right? And this is where my check bounds function is. I want to make it so that when my plane moves to the right and it's half the width is off the screen, the program will push it back. So it's inside my screen. I'm going to create a boundary so that it can't leave the screen. I can do that in my game, in my plane. So if I go to objects, and if I look at plane, here it is. You can see that I have my check bounds function, but it's empty right now. So I want to say something like this. Here's my right boundary. And there's also my left boundary. I got to check both, my left and right boundary, right? My right boundary is going to be a little tricky. It's going to say if this.x is greater than or equal to 640 pixels. Now I'm actually hard coding it right now. Eventually I'm going to make it so that it's not hard coded. I'm going to use a configuration file to replace this with an enumeration, because then I can have different size screens. I can also make my screens, my website be responsive, so I can have different kind of screen sizes. I can run it on my phone. But right now I'm just going to make it so that it is fixed. So if it's greater than this, you know, plus this dot half width, this is where I need the half width, right? If that's true, then what I want to do is I want to say that this dot x is equal to 640 plus this dot half width. If it's greater, I'm going to make it equal. I'm not going to allow it to go beyond that. And if, by the way, this might be wrong. I might have to put minus 640 minus this dot half width. I'll see how that works. Let's see how it goes. But if I run it now, I can see that it goes like this. I'm pretty good. I want to put the minus in there, right? And let's start again. So if I go here, then, oh wait. First of all, this dot x is greater than or equal to 640 plus this dot half width, right? So this has to be minus 2. Start again. Yeah. So now no matter what I do, I can't pass the screen, which is going to help, right? Because now I can't cheat. Let's do the same thing on the left boundary. A little bit more tricky. This dot x is less than or equal to, right, negative this dot half width. If it's less than half its width on the screen, I'm going to make it to equal to half its width. This dot x is equal to this dot half width. So how does that work? When I play it, I can't go beyond, no, that doesn't work. So less than or equal to negative this dot half width. And what I'm saying is less than or equal to half this dot half width. Better check. Now it doesn't allow me to go past this way or this way. So I'm kind of clamped, if you will, inside this area. And that's what the boundary check is for. Boundary checks to see if it's the bottom or the top, the right, the left, and it allows me to do different things. Actually, you can use a boundary check if you think about it for collisions. All right, so the plane is done. So I've added my plane to my scene. I'm going to go back to GitHub. These are the 13 files I added. Added plane to scene. Any questions so far? I know I've covered a bunch of stuff. I've made a game object. I added my plane to my scene. I did a bunch of stuff, right? So 2 more things I need to do. I know it's pretty straightforward, but 2 more things I need to do. I need to add my island, which is where I pick up points, and my clouds, which is the thing that kills me. Okay, so then I almost have a game. I have my pickup, I have an enemy, I have my player. You know, the only thing I'm missing is collisions, which I'm going to do next week. Okay, and sounds. Question? Okay, think about it after, maybe we'll talk after. All right, so I want to add in my cloud. Let's do that. So new file. I want to talk, my island first, my island.ts. My island.ts is like my plane, so I'm going to take my plane for a second. Now, if I start saying like my plane, it's almost like I'm copying over and over again, but there's a reason for it. Again, I could inherit, but it doesn't make sense that my plane is an island, or my island is a plane. It doesn't make any sense, right? So that's why we inherit from game object. So instead of my plane, it's going to be an island. I'm going to pass an island in here. Now, here's where it changes. My start is not going to be 430. My reset method I didn't use before for my plane. This is not going to move on my mouse X. And my boundaries is not going to be left and right. I don't care about my left and right boundaries from my island. One thing I need to do, though, in my start method is I need to set my speed. I'm going to say that on start, I'm going to say that the dy value is going to be equal to 5. So it's going to be the same speed as my ocean. because my island doesn't make sense. The island can go faster than my ocean. It's going to look weird. What is it? The island is some kind of boat, right? It doesn't make sense. Island and ocean kind of travel at the same rate. It's going to make it look like the island is part of the ocean or part of the world, right? Also, I want to reset. What is the reset for the island? Well, it's kind of the same as the ocean. So I've got my ocean, and let's load up my island. So let's load up my island for a second, just to give you an example so you understand what to do. And for the people watching this remotely, it could really help too. So here's my ocean. I've got my island. Okay. Let's try that again. Copy. Paste. There we go. There's my island. And if you notice my island, I'm going to zoom in here. My island is going to start like this. I'm going to have my ocean here like this. And my island is going to start somewhere on the top, off screen. And it's going to come down like this. And when it comes to the bottom of the screen, it's going to reset to the top of the screen again. But instead of it starting at the same place all the time, maybe it's going to be here. Maybe it's going to start over here. Maybe it's going to start over here. And it's going to look like it's a new island with the same exact shape for now, right? In the future, I could have multiple island shapes, so it doesn't look like the same all the time. But if you notice, I talked about it being in a different position every time it resets, right? For me to do that, I need to randomize this the way it works, right? Which means I need to use a math.random function. The way math.random works is it gives me a number between 0 and 1. That's what math.random does, right? So it's a normalized number, 0 and 1. And then I'm going to multiply it by the screen width, right? Minus half of the size of my island, so it doesn't come off screen like this. It only appears here or up to here. And then it's going to just come down, and when it resets, it's going to reset somewhere else, wherever it's going to be. That's how my island's going to work. So I'm going to reuse my island, just like I reuse my ocean. So then, if I know that's how it's going to work, in my reset function, I want to do two things. I'm going to say that this .x, the location on the horizontal, is going to be a random value. Math.random multiplied by the size of my width of my screen, minus the width of my island, right? So this part here, I'm going to subtract. I'm going to put all this in brackets so you can see a little bit more clearly what it's going to do. And then I'm going to add this half width. What I'm going to do basically is I'm going to again constrain it within inside of the bounds of my screen. That's all it's happening. It's going to generate a number between something like, because I know my island is approximately 64 pixels, something like 32 pixels, from 32 pixels all the way to 600 and something, 610 or whatever it's going to be. Yes. Should it be a integer? I could, you know what? It's going to generate a floating point number. If I make it, if you want to be a stickler and generate an integer, you could. And then from there, you just go math.floor. That'll make it an integer. So you can make this whole thing a math.floor. So then you're kind of rounding down. You're taking away. That would be the correct way of doing it. But if you made it a pixel that's 1.2 pixels, it's not going to hurt. Actually, it'll still calculate everything. It just will discard the extra information. Okay? But it's okay to do this too. So now this is on reset, it's going to do this. And I also want to start it off at a certain position. It's going to start off this .y, the y coordinate is going to be off screen again, right? Which is something like a negative this height. So it's going to start off the screen like we said before. The full height of the island is going to be off the screen like this, at some random position. And then it's going to come down, right? Here's my move function. And what I'm going to say is that this .y plus equals to this .dy. So the same speed as my ocean. My boundary check. I'm going to check to see, so check lower bounds. All I care about. So I want to check to see when this thing leaves the screen, right? And then reset. My boundary check is going to say, well, if this dot y is greater than or equal to 480 plus this dot height, right? Then this dot reset. Oh, makes sense? So I'm going to check to see if it's below the screen and then resetting, right? And I'm going to check bounds and move every frame. Every frame I'm going to move and check bounds, move and check bounds, move and check bounds until I know that I'm off screen. That's my island. My island is ready to go. But I got to add it to my index.html. I got to add it to my references. I got to add it to my scene, and then I can make it go. So let's add it to my index.html first. So here's my index.html, my plane. I'm going to add in my island. Right, I'm going to add it to my references. So again, core references. Just like I did my plane, I'm going to add in my island. Oh. And I'm also going to add it to the scene. So this is where the fun stuff starts, right? In my scene, in my play scene, I have an ocean and plane. And I'm going to add an island, which is going to be type objects.island. And then, just like I did before, I'm going to add another island object right here. And this is of type island. And I'm going to update it. Oh, typing is terrible today. And then I'll add it to the scene. I know there's going to be a problem. What's the problem? Yes, the layering. Let's show it. Here's my screen, and uh-oh. That means that there's a problem. Let's inspect and see what the problem is. So object island is not a constructor, right? It's not a constructor, and that's in play.ts27, right? So let's take a look at that. I made a mistake typing or copying, right? This island is equal to a new objects.island. I'm passing in the island, the asset manager. That's what I'm passing in, right? That's correct, right? Here's my island, objects.island. Right? Let's take a look at my constructor for my island. So again, nothing to worry about. We'll figure it out. But, you know, it's just, we have to look and see. So there's my island. I'm passing in my load queue, my constructor. Here's my start function. I'm calling my start function for my constructor. Here's my update, my move, my check bounds, reset, move, and here's my check bounds. So I don't see a problem. What does it mean? Also, just to make sure that I've loaded it properly into my index.html, these are all things I check, right? My objects, my island, and inside my island itself. So let's just save everything again, and maybe that will solve it. I don't know. There it is. Yeah. Now you can see that my island is going to start at different positions, right? Now it's kind of starting, there you go. So it's kind of randomized, pseudo-random number generation, right? To start off where it is. Oh, but what the hell? How come? Because like we said, the layer order is wrong. So going back to my scene, if I go to my play, what I did was on purpose, I put my island underneath my plane, and this is exactly what's happening. It's layer order as I add. So I want to put my ocean, then my island, then my plane, right? But you can. You can change programmatically by this.addChild at. So you can specifically point where you want it. And then you have to keep track of your display list, right? Which you can make an enumeration for. There's other ways to do it, though, is what I'm saying. I mean, this is the cheapest and easiest way, not the best way. So if I start it again, you can see now that my plane is over my island, right? Not underneath. And it's pretty good, right? See? All I did was change the order that I added it, right? I'm just showing you this because you're going to run into this problem. You're going to say, oh my God, it's not working. It's not showing up. Maybe it's underneath. Maybe you didn't add it in the right layer, okay? So we added my island. We added my ocean. Let's put this up on GitHub. So added island to the scene. We're going to add one more, and then we're going to be done for the day. And we got to talk about it because this one's more difficult. Because I want to talk about what the clouds are going to do. So the island so far is pretty straightforward, but the clouds, you know, they need to be more interesting. They're going to have some kind of challenge for the player. So what does the cloud look like, first of all? It's pretty big, and it's done on purpose. So if you look at the cloud, this is not part of the original 1942 set. This was made by somebody. So this is kind of a big cloud, and it's not really, doesn't really match 100% the style of the game, but I kind of like it because it gives me an idea of what to do. So there's my cloud. Now my cloud is like the island. It's going to start off screen, right? But what's going to happen is as the cloud comes down, right, it's going to come off screen to here and then reset. It's going to reset like the island. It's very similar to the island, but here's what's going to happen. The cloud is going to have different speeds. Some are going to be slow like the island. Some are going to be fast. Some are going to go to the left. Some are going to go to the right. Okay? And there's going to be 3 of them. Okay? So, strategies. I need to do almost what I did with the island, but I need the cloud to be duplicated. In my mind, there's 2 ways you can do it. Cloud 1, Cloud 2, Cloud 3. Boring and wrong, right? Or a cloud array. Cloud array is an object array. And that is, my friends, where we start getting into more complex structures, slightly more complex. Let's do the second one, cloud array. So now let's talk about the cloud. Let's add the cloud in first for the get-go. So I'm going to go back to my objects. I'm going to add a new file. I'm going to do cloud.ts. And I'm just going to copy the ocean for now, or the island. I mean, the island is the closest one because it's like the island, but it's a little bit different. And again, you can think about how to make a better system than this, other than using multiple inheritance. You know, in C++, you can use multiple inheritance to only use the components you need, right? Or in iOS, you can use protocol-based programming where you define your interface and extend it. So all you add is the components you need, not all of the components all the time, like this monolithic class I've got. All right, so here's my cloud. It's like an island, but my start method's not going to be, it's not going to define my speed. My speed is going to be defined every time I reset. This is going to be the same, but this is the main method that's going to change, right? My check bounds is going to be different, and my move is going to be slightly different. So here's my move. My move is going to be this dot x plus equals to this dot underscore dx, because I'm also going to move my cloud on the horizontal too, right? Not just vertical. My reset is going to be where the heart of everything is. How do I do the reset now? So this is correct. I'm not going to change this part. It's almost exactly like the island. And I'm still going to put it off screen, this minus height. But here I'm going to define speeds now. So this dot dx, so the speed in the x direction, is going to be something like from -2 pixels per frame to +2 pixels per frame, a slight drift. I'm going to be calling it this like horizontal drift for the cloud, okay? So I need the same kind of function I have here, math.floor, math.random, but instead of it being 640 and some of this other stuff here, let's just wipe it out. Some kind of value plus some other kind of value. All right? So think about this now. I want it to go from 0 to, it goes from 0 to 1, right? And I want to go to maybe from 0 to 2 and then subtract 4. This is how it can work. So 0 to 2, and then I want to subtract 4 from it. How does this work? So it goes from 0 to 2, and then if it's 0, if the random number produces 0, right, then it's -4. But that's not right, right? Okay. What about if it's 0 to 4? If I go 0, right, if I go 0, then I'm at -2. If I go 4, I go at 2. That's right. So from -2 to 2. That's what that will produce. And then I'll do the same thing for the y. Yes. Is that a question or no? So here's the y. So I'll change the y. So for the y-axis, I'm going to go, it's going to start off at 5, and I'm going to add 5 to it. That means that for the y-axis, I'm going to go from at least 5 up to 10. So I can have fast clouds, and I can have clouds as slow as my islands, but no slower, right? There we go. So there's my function. There's my cloud. Does it make sense? So I'm not just resetting and randomizing my location on the horizontal, but I'm also randomizing my speeds. So it's going to produce a different looking cloud every time, or a different performing cloud every time. Same looking cloud. All right, cool. Well, this is okay. But I need to add it to my index.html, just like I've done before in the past many times. This is an object. So here's my cloud. And I also have to add it to my references for the future. We're going to need, you don't know why yet. You'll see. Swear. I'm not just wasting your time. And I need to add it to my scene, which is the most important thing. Right, so I'm going to go back to my scene class, into my play scene, and at the top, this is where we go a little crazy. So for those people who don't know JavaScript so much, let me explain. Private. I'm going to call it clouds. And instead of an object.cloud, it's going to be an objects.cloud array. That's the syntax. So it's going to be a cloud array. That's number one. So instead of me doing cloud 1, cloud 2, cloud 3, I could have done that and then updated cloud 1.update, cloud 2.update, cloud 3.update. And then cloud 1 is equal to new object.cloud. Cloud 2 is equal to new object.cloud. Cloud 3 is equal to, it's a lot of duplication, right? I do this. I make a cloud array. In the start scene where I did this, I'm going to generate my cloud array. So I'm going to use a for loop. And one thing I'm missing is some kind of cloud number. For now, I'm going to make a private variable called cloudNum, which is of type number. And I'm going to say that my cloudNum starting off, cloudNum, cloud number, is equal to 3. So 3 clouds. I'm going to say that I'm going to count my loop. In my loop, I'm going to check that it's less than cloud number. And inside my loop, what I'm going to do is say something like this. This._clouds count is equal to a new objects.cloud where I pass in this.asset manager, which I don't know why I'm doing that every time, but I know. One more thing to do is this will cause an error. Why would this cause an error? Does anyone have an idea? The way I've done it so far. So far, I've declared the variable. Here it is. And then I start adding to the variable. What's the problem? Huh? Come on. You smart people. Which one? What is it? The array is not created. You're absolutely right. And the reason why is unless I create the array, there's no container to put my clouds into, right? So I need to do that first. So in here, I'm going to say that this.clouds is equal to a new array of type objects.cloud. This is the syntax, my friends, that you need. It's just like Java. If you know Java, it's identical to Java. Yeah, okay. So again, different ways of doing the same thing. So once you've done this, I've got my cloud array. So this is, so again, steps, declare or instantiate my cloud array. I can't answer the phone right now. I'm in class. Right, that's the first step. Second is, loop and add each cloud to the array, right? So I'm building my cloud array with the clouds. That's what I'm doing. This part here can almost be taken off, this part here, and I can put it inside of its own method called cloud builder. Call my cloud builder, yes.
Are you going to have always defaults?
For now, yeah. Yeah, for now. In the future, I might add it so that every level has different clouds. Maybe the first level only has one cloud. Second level has a couple clouds and maybe an enemy. Third level might have 3 clouds and a couple of enemies. The fourth level, you get what I'm saying, right? You can add more and more stuff to make it more complex, more challenging for the player. But each cloud is going to have its own behavior, as you're going to see in a second. Okay, so I built my clouds, my cloud objects, right? And now I need to update them. And I need to do this every frame. I need to use a for each loop. So you can use a for each loop. The new one in JavaScript is also a for in you can use, where you're going to say this dot clouds. For every cloud in clouds, that's what this does. I want to have my cloud perform its own update. That's a for each loop. So for each cloud in clouds, update, right? So I don't have to update them into cloud 1.update, cloud 2.update, cloud 3.update, cloud 10.update, whatever, right? Then I gotta add them to the scene, right? And I'm gonna add them after the plane. Well, it's gonna be very similar to this loop that I'm doing, right? And some people may say, well, why don't you add them right here? Yeah, I could, but the problem is it won't add properly. It won't add in the same order. If I add them here, all my clouds are going to appear underneath my ocean, right? So I have to add them down here. So add clouds to the scene. I only do this once anyway. And I'm going to say that this cloud is what I'm going to add. I'm going to say that this dot add child, this dot clouds counts. You can do it that way, or you can do a for each loop. For each loop again, right? So I can say for each this dot underscore clouds. For every cloud element, right? This dot add child cloud. That's also another way to do it. Same. This might be cleaner, right? But I need to do that loop 3 times, right? Twice to build the clouds, once every frame to update them. So I'm updating all the clouds. I'm going through each of the clouds and updating all of them. This goes back to what I talked about before, which is, what if all the objects update themselves somehow? And there's a way of doing that we're going to handle when we optimize later on. Can't optimize now. Okay, so we've done it. We've added the clouds. Let's see how it looks in the scene. Start. So you can see how they have all behavior, different behaviors, right? Some are fast, some are slow, some move to the right, some move to the left, right? It makes it so the game is more interesting, right? Still, I can move around with my mouse, which is an advantage because I can really zip around here, and that's the problem. I should be able to stop myself from doing this, and we're going to move away from using the mouse and use keyboard, which is better. But you can see right now we're bug-free, we're running, and it looks like the game is never ending, which is what I wanted to create, a never-ending level. Procedurally generated clouds and enemies every frame, and all they're doing is they're just resetting. I'm not instantiating new objects. The plane goes under the clouds, over the islands, and above the ocean, right? And everything works and performs fairly good, as you can see. So I'm operating right now at 60 frames per second, no problem, on my little machine here, running the server that's on my machine. The next step is to actually deploy this to a cloud service, right? Or some kind of place. And one of your jobs is to deploy your game to some kind of live site, right? Because you're making a website at the end of the day, right? So one thing I didn't have a chance to cover this morning, which I'm going to cover with you now, because I'm done for today, is where to deploy. So I'm going to go here and I'm going to say added cloud scene. I'm going to add this to the staging area and push. So now you have all my cloud data too. So this is really good for multiple objects, right? Now I know that some people in the first class or first section wanted to make some car game where the car games, you know, you have cars coming down, and that's fine. All I ask is don't make the cars intersect. So you don't want to kind of make them go, it doesn't make any sense. Clouds, okay, they're clouds, right? Cars, no, right? Cars would crash into each other. They wouldn't intersect. They don't fly over each other. And don't make it for space games either. Don't like this, let your two spaceships, you're like, hey, Tom, they're different levels. So I got that sometime too. Oh, the different levels of spaceships couldn't cross over each other. No. If you're making them at different levels, make them smaller and bigger. Make them appear below and above. You know, that kind of stuff. That makes sense. So they're the same size, they're going to crash into each other. Okay? But where do you host this stuff, right? A great place to host this is on Github Pages. So if you go to Github Pages, let's do this together, guys, because you're going to need this. For Github Pages, the great thing is that it gives you some really interesting and easy ways of hosting. It's free. There's nothing to pay. And it gives you a whole tutorial on how to do it. So here's create a repository. Let me just like put this thing on Slack for you guys. So here's GitHub Pages on Slack. So the way you do it is you create a repository. The repository is the name of your account .github.io. It has to be the exact way of doing it. So let's say, for example, your account is Tom. Then my new repository has got to be tom.github.io. That's what my repository is going to be called. Now I've already done that. If you want to take a look on my, well, I better plug in somehow. I didn't realize I'm not plugged in. That would be bad if my computer died. If you look at my Tsiliopoulos.com right website that I showed earlier, this one, this is actually hosted on GitHub Pages, right? And the way I did it was, if I go to my GitHub by myself, my actual GitHub page, right here it is. I have a repository that way. So if I go to my repository, so if I go to me, my profile, and if I look at my repositories, right? Look, Tsiliopoulos.github.io. In there, I have my files for it to work. If you want to, you can also have a custom site like I did, but you need to have a CNAME file. The CNAME file points to www. whatever my file is called. I bought this domain, Tsiliopoulos.com. You can also buy your own domain for your game. And you can get it at GoDaddy. Sometimes they have really cool sales, like $1.99 for the whole year, right? So it's not a big expenditure. Like let's say my game was called My Crazy Funky Game, right, .com. Let's say I wanted to make that thing, right? Well, if I search for it, right, mycrazyfunkygame.com is worth $14.99 per year, right? However, if you scroll down, you can see that mycrazyfunkygame.ca is only worth $4.99. And somewhere down in here, you might find My Crazy Funky Game. Whoa, Funky Game is $2,700. But sometimes you might be able to find like mycrazyfunkygame.club or even better, mycrazyfunkygame.xyz is only $1.49 per year. So just be careful. Just cancel it at the end of the year, because then it'll be $20 every year after that, right? But who cares? It's like $1.49, and you can buy your own domain and point it to GitHub, right? Point it to GitHub, and then in GitHub Pages, you can host your files. So all you need to do is take your repository, a copy of your files, put it on GitHub Pages inside this thing that says the account name .github.io, right? And if you point to it, you're good to go. You're hosting for free, right? So I think this is a really great solution for students, right? Especially when you don't have anything there's no back end to what we're doing. We don't have a database or some kind of funky, content management system or node server or something like that. It's okay, right? And it's free. And I think it's a really great thing that GitHub does for that. So the way you do it is you create your GitHub page, your GitHub repository. It tells you how to do it if you're using a terminal or GitHub Windows or GitHub for Mac, or you don't know, right? You clone the repository, and what you do is you just upload everything into the repository, and you're done. As long as it's called username.github.io, where your username is the account name, that's it. Like, it's that simple. Using Tim Cook's way of speaking, right? Because he always says, well, Apple products, it's that simple, right? It's that simple, guys. There's no funky way about it. That's how simple it is to set up your own GitHub pages, right? I think it's amazing. I think it's easy, and I think it's fun, and I think you can put up your game and you can share it as part of your portfolio as a software engineer or a game, if you're part of the game program. All right, any questions around GitHub pages or what I've done today? So stuff that's missing. So we've got this, but we've got no collisions. And we're going to handle that next week. And the other thing that we don't have is we don't have any sounds. It's pretty quiet, the game right now. We want an engine sound. We want some kind of sound when we run over the island. When we collide with the cloud, we want those sounds. We're going to do sounds and collisions next week. They're related. As well as we don't have a score. I don't have how many lives I've taken up. I don't know how much score I have. And also, the fonts that we can use are really boring. I want to make my own custom font, right? And I can show you how to do all that next week when we get together. So just to recap before we stop recording for now, remember that next week, your first playable build is due. It's not a presentation. It's just a build. So I'm going to come around next week at some point, and I want to have a quick view of what your game looks like. I'm also expecting, if you remember the requirements, that you're going to have version 2 of your game design document, because you're going to know more about it. You're going to know more about your game because you're going to have worked on it a little bit. I don't expect anything crazy. I want movement. If you can do collisions, fantastic. If you can't do collisions, I'm going to be talking about it next week, right? And it's due that night. So it's not like you can't incorporate what I'm going to tell you the same day, right? It's pretty simple what I'm going to do for collisions as well. Any other questions for what's due next week? So remember tonight, please do your peer review. There is a Dropbox for that. It's worth 1% of your final grade, and it just talks about how I rate my team. Is Ashley, if I'm working in a team with Ashley, and it's me, Ashley, and let's say Elsa, I'm just giving some names, 3 of us. And is it 33%, or did Ashley do all the work? Is it 50%, and then we have to share the other 25? Like, how is it working? I'm saying, right? You don't know how it's going to be, right? Or did we all contribute equally? Or did somebody not contribute at all, right? If someone didn't contribute, I think it's a great time, guys, to identify this so we can fix the problem, because it's going to snowball. It's going to be a small problem now, and then that person's not going to contribute, and then it's going to be a real big problem later on where you need help to finish your project because you have other stuff going on at the same time. That's it for me. I'm going to see you guys next week. Remember that the following week, I believe there's no class. March 4th, there's no class, right? So next week is the last week of class before the break. Okay? Take care. See you next week.